Section 3.6, Polynomial and Rational Inequalities. First, let's take a look at how to solve polynomial inequalities. Since you've seen this before in a previous section, I'll go fairly quickly, but I did write down the steps just in case you need to review. The first thing you want to do is set one side of the inequality to 0. And I'll do that by subtracting 3x to both sides and adding 2x cubed to both sides. I'm also going to write it in descending order because this will be easier when I factor. Which brings me to the next step, factor the polynomial. The very first thing you want to do is to see if you can factor out a GCF, or a greatest common factor. And in this case, we do have a GCF. Do you know what it is? If you said x, then you are correct. Go ahead and factor out your x. And now we can factor the quadratic, the 2x squared plus 5x minus 3. And that factors out to 2x minus 1 times x plus 3. The next step is to find all your zeros. And remember, these are the x values that make each of our factors 0. And therefore we get 0, 1/2, and -3. Next, we write all our zeros on the number line. It is important to determine whether our zeros are part of our answers or if they're not. So in other words, should I write open or close circles on -3, 0, and 1/2? To determine that, let's take a look at our inequality. So from now on, I'm going to use the factored one. It's just nicer and easier to work with this one. So let's take a look at our inequality. Now, if you look here where I'm pointing at, we have greater than 0. That means that we do not want to include our zeros in our answer. If I had greater than or equal to 0, then we do include them. But because I don't want to include the zeros, I don't have equal to 0, we write open circles on our number line. So let's go ahead and do that now. Okay. So now that we have open circles, I want to determine whether I have positive answers for each interval or negative. Now notice that we have 4 intervals. Our first interval is from -infinity to -3. Our second interval is from -3 to 0. Our third interval is from 0 to 1/2. And our last interval is from 1/2 to infinity. So we have 4 intervals that we need to test. And the way we test them is we pick any number in between each of those intervals and plug them into our inequality, the factored form of our inequality. And I'm going to highlight it over here so you can see it. Okay, so this is where we're plugging in a number from each interval. Let's start with the first interval. Now, if you remember, I said that it's easier to pick huge numbers because I don't really want to do the math. I just want to know whether I get positive answers or negative answers for each interval. So instead of plugging in -4, I'm actually going to choose -1,000,000. So if I plug in -1,000,000 into x, I get negative. If I plug in -1,000,000, sorry about that. If I plug in -1,000,000 into the x, I get negative. If I plug in -1,000,000 to the 2 times x minus 1, I again get a negative. And if I plug in -1,000,000 into the x plus 3, I again get negative. See, I'm not even doing the arithmetic. All I'm doing is trying to find whether I'm going to have positives or negatives. So now we have negative times a negative is a positive, and positive times a negative is a negative. Okay, so this interval, no matter what numbers we choose from -infinity to -3, we're always going to have negative answers. Now, I can plug in numbers from each interval to determine whether I have positives or negatives, but I'm going to just use the shortcut. Hopefully you still remember the shortcut. If you don't, I'm going to go through it pretty quickly. Okay, the negative 3 came from which factor? If you said x plus 3, you are correct. Now that factor has an odd power because the power is 1, and I just wrote it in red. When the power is odd, the next sign changes. So because the previous sign was a negative, the next one is going to be a positive. Okay, now let's take a look at the 0. What factor did 0 come from? If you said x, then you are correct. And the power on the x is yet again odd. And again, since the power is odd, the sign changes. So we went from positive to negative. And then a half, again, comes from an odd power factor. And that changes the sign again. If the powers are even, remember that the signs stay the same. So if negative 3 would have came from an even power, the next sign would have been negative. We wanted to stay the same as the previous one. Okay, let's move on. Now that we know the answers in each interval, whether we get negatives or positives, we need to actually determine what our answers are. Which intervals do we want? The positives or do we want the negatives? Well, we determine that by, again, looking at our inequality. Okay, so I wrote here, if a is greater than 0, we obviously want positive answers. If a is less than 0, we want negative answers. And then also keep in mind, and we talked about this a few seconds ago, that if we have less than or equal to and greater than or equal to, that means we include our zeros and we want brackets in our interval notation. But if we have less than or if we have a greater than, we don't include our zeros and we use parentheses. Okay, with that being said, which ones are our answers? Do I want the positive ones or do I want the negative ones? What do you think? Okay. Well, if you said positive, you are correct because we want all the x values that give us greater than 0. That means we want our positive answer. So we have this interval from negative 3 to 0 and this interval from a half to infinity. So I'm going to go ahead and write my interval notation. So my answer is from negative 3 to 0 union 1/2 to infinity. Okay, that's our answer. Okay, next, I did want to make a side note that the way I do my work is by using a number line. And I really like that because for me, it just makes it clear and I can see what's going on with whether I have open or closed circles. Now, what I wanted to mention is that my math lab uses this table. And the reason I wanted to share that with you is because they will ask you to fill out the table, which is very similar to my number line. But instead of writing a number line, they write the intervals. Okay, so the first interval was from net infinity to 3. The second one was from negative 3 to 0. The third one from 0 to a half. And the fourth one, a half to infinity. And then they write the signs right underneath, which if you look at my number line, I just write them on top. But it's the same concept. Okay, just wanted to make sure you knew that. I mean, we still have these same answers. We are still shading the positives. These are our answers, the positive ones. Okay. Please join me for part 2, where we're going to solve rational inequalities, and those we haven't done before. Thank you.